Hi guys, how's it going? So in this lecture we'll be covering an example of using the comparable interface. And I briefly talked about this at the end of our last face-to-face lecture on generics. So if we go ahead and just get into the slides here, if you remember, generics was great except for since you don't know what type you're working with, that means you don't have any methods to your disposal, or at your disposal, other than, the ones inherited from the object class. And so this becomes kind of useless, right? I mean, okay, you don't know what type you're working with, so how can you do anything with the variables of that type? For example, how do you compare two objects of, let's say, type E, right? You use a generic type E, how do you compare them? Well, you can't use the equality operator, it won't work. And that has to do with, remember, objects are reference types. And a reference type, the actual value stored for that reference type is a memory address. And so when you're using equals equals, what it's doing is it's actually just comparing the value associated with the two variables that you specified. And if the two variables are two memory addresses, then you're going to get very weird behavior. Equals equals is meant to be used with primitive types, unless you really know what you're doing. And so before we get into the comparable interface, we have to show, and I've already gone over this slide, but you can enforce inheritance as well as interfaces on the generic types that you want. So in this example here, we've got class foo, and okay, we specify generic type E, and it's going to extend some interface. And yeah, so the extends keyword is a rather weird use here. Normally, you use implement, which is the syntax used when you're creating a class and you're trying to implement an interface. You use the implement keyword. Well, in this case, for generics, for some reason, Java has decided that they will enforce only the word extends. So you use, in this case, E extends an interface, or E extends some class. So why is this useful? Well, okay, think about it. When you enforce an interface, you're enforcing that whatever type that the user will specify of your class, that's going to replace type E, the placeholder, that it must have certain methods implemented, specified by the interface, or properties and methods that are inherited by whatever class you might have specified. So Java, the convention for comparing two objects is to implement something called the comparable interface. And the only thing the comparable interface has that's useful is the compare to method. This method takes in an object and will return an integer. Basically, that integer is going to be a negative value, 0, or 1. Or, I'm sorry, a positive value. A negative value being returned means that the current object is less than, in some way, shape, or form, than the input object. This guy. Returning a 0 means they are equivalent by whatever metrics you've set. And greater than 1, or greater than 0, I apologize, means that the current object is greater than the input object. So we're going to go ahead and dive into an example of this. So as you can see here, I have my main class, and I already have the main method, and I have just this my generic class. So I'm going to start with, first, since we're talking about generics, let's make this class generic. So angle brackets E. I'm just going to use E for this. And we're going to hold a variable of type E, private E. And this variable, so what it's going to do is store the greatest valued item. So we'll call, and I'll show you what that means in a second here. So greatest value item. And so we'll go ahead and create a constructor, public my generic class, specify the input of type E, call this init item. We'll say greatest value item equals init item. Notice I'm not using the this implicit parameter this time. Remember, that's only needed if you really need to distinguish between your class variable versus an input parameter. In this case, these have two different names, so I don't need the this implicit parameter. Okay, so this is great. And now let's add a method. We're going to call this method, here we go, public return type E, update item. And the input is going to be the new item, or the prospective item, rather, that might replace the greatest value item here if it itself is greater. I'm going to go ahead and do some fancy documentation stuff here. So notice how this all gets auto-generated. It's because I did the /**. Param is new item, which we're saying new item is the prospective new item will replace greatest value item if it is greater than the greatest value item. And what are we returning? Okay, so we're going to return how do I want to do this? Okay, so we will return the item with the lowest value. And so what is this saying? So basically, if new item is greater than the greatest value item, then we're going to return the greatest value item. And then replace, and prior to that, replace the greatest value item to be the new item. But if this is not the case, and the new item is actually less than the greatest value item, then we will return just the new item. And I can add some comments here. So a little redundant, but we'll update the greatest value item variable with the new input if the new input is greater than the current value of greatest value item. So basically the same thing as I was saying in the new item. So really I could, if we're looking at comments here, I can probably just erase this right here, prospective new item, that's fine. Okay, so we have our method. It's getting mad at us, it's saying, hey, missing a return statement, you specified return type E. So what do we need to do? Well, we need to compare somehow new item to greatest value item. How are we going to do that? You can't do something like this if greatest value item is greater than new item. You want to, but you can't. This is saying, you know, you're basically using an entire object and trying to use a, you know, the greater than symbol here to an entirely different object. You can't do that. And the issue is you don't know any of the properties these items hold, or any of the methods. So you have no real way to compare them. And this is where the comparable interface comes in. So we're going to go ahead and specify up here, and this is the syntax, E extends, and so the interface name is comparable. And as you can see, it's already built in, so we want the comparable, not comparator. Comparable. Now this is what gets interesting. The comparable interface also has generics. And so just like the array list that has generics and you specify what type your array list might hold, the comparable is the same way. You need to specify, in this case, what you're going to be comparing to. Well, in our case, whatever type E is, we want it to be able to compare to itself. And so the input, or the type to specify for comparable, is E. And so basically what this is saying is my generic class is going to use this E placeholder, and I'm going to enforce that this E placeholder, whatever type the user specifies, it must implement the comparable interface. But not just the comparable interface, it must implement a comparable interface that can compare to itself. So now we're going to have some methods at our disposal, and we can see this. I'll go ahead and type greatest value item, dot, and look at this. So all these other methods are all part of the object class, right? But this compare to is specific to the comparable interface. And notice how it says compare to ET. And the return type here is an int. Well, this E is only here because I specified in the generic type of comparable to be E. If I had wanted it to be something else, let's say T, now I'm going to have to do some fancy stuff here, but T, for example, we go here, compare to of type T. So it's telling you what it's able to compare to given your current circumstances. But so we want it to be type E. And we'll say dot compare to, and the input will be new item. Now it's getting mad at us. That's because an if statement requires a Boolean. But remember, compare to returns an integer. And so what we want to see is, okay, is the new item greater than the greatest value item? Let's see here. Or in this case, I mean, there's many different ways to do this. I'm going to say, is the new item, or is the greatest value item less than the new item? So less than 0. What this means is, if compare to returns a negative number, then that means new item is greater than greatest value item. Or, you know, thinking of it the other way, greatest value item is less than new item. And so what do we want to do if this is the case? Well, we want to replace the current value of greatest value item. So you might jump to this conclusion. New item. Great, okay, so we've replaced the greatest value item. But if you remember, the issue is our return type is the item with the lowest value, which currently is the greatest value item. And in reassigning the greatest value item's value, we've lost the previous value of greatest value item, which is the lower value item. So actually what you need to do is create a temporary variable to store that value. And so what type will the temporary variable be? Well, it's the same value as the greatest value item, or the same type, and will be the same value. So it's type E. And so we can do prev for previous greatest item equal to greatest value item. So this is going to store the value or the object for greatest value item. Then we're going to update the greatest value item variable to be the new greatest value. And then we're going to return the previous value greatest item. And so it's still getting mad at us. It's saying missing return statement. Well, that's weird. We do have a return statement. So what this means, what this error is saying is it's possible what happens if this compare to comes back to be equal to 0 or greater than 0. This if statement would then fail, and then there is no return statement here. So that's what it's saying, is you're missing a return statement. Well, conveniently, right, this is the only case we really care about. If any other case comes back, and I'm going to assume, you know, a tie, meaning they're equal in value, you just leave the greatest value item as it is. So we'll do return new item, and this will suffice. So how can we test this? Well, let's go to main. We're going to do my generic class. Remember, we need to specify what the generic type will be. In this case, what we're going to replace E with. And I'm going to specify an integer. And we'll call it mgc equals new, my generic class, and the input, I don't know, we'll make it 5. So first of all, what does this tell you about the integer class? Well, the integer class implements the comparable interface by default. So it has a compare to method. Okay, so this is great. Now we can do mgc dot update item, I don't know, 6. And we want to see the result of this, so system.out.println. And right now we're testing to make sure the code we wrote works. And so the input item we have is 6, so it should be replacing the 5. And the 5 should be getting returned if our update item is working appropriately. So we'll go ahead and run this. 5, good. But now we also want to see, we also want to see if the current item inside of MGC works. And this is where a print statement can be useful. So I'm going to go ahead and add a print statement within my class. Public void print, or I'm sorry, print method could be useful. System.out.println, and we're going to print the greatest value item. Now, I'm going to explicitly write this, but you don't need to because it's assumed. But since greatest value item is an object, what we're calling here is the toString method. So if I get rid of this right here, the toString method is what gets called. So now we can do something like this. We can do mgc.print. So we'll know that this first output is going to be 5, but print, since supposedly our greatest value item is getting updated, print should print 6. And indeed it does. So our class is working as we expect. So, you know, integer was nice, but what happens if you are the one using a class that is requiring the type to implement the comparable interface? So let's go ahead and do that. Let's implement the comparable interface. I'm going to create a class. We'll go ahead and call this my comparable class. And so the first thing we're going to do is implement comparable. So it has an issue. Class my comparable class must either be declared abstract or implement abstract method compare to T in comparable. What this is saying is comparable is an interface. It's asking you to implement the compare to method. But you haven't done that yet. So it's getting mad at you. So we'll go ahead and implement the methods. This is me being fancy. Thank you, IDE, for doing this for me, or IntelliJ for doing this for me. So bam, all right, cool, it's fixed. But there's an issue here. What is object? It is specified basically that the compare to method can take in anything. And this is actually not what we want. And if we look over at comparable, it says the raw use of parameterized class comparable. Well, we've seen this before, right? This is what happens when you use a class or an interface that has generic types, or specifies that it wants generic types, and you haven't specified what type it should be at compile time. So in this case, we're going to replace this. And if you recall, right, in the myGeneric class, E extends comparable E, we're saying is we want a type that extends the comparable interface that is comparable to itself. And so that's what we're missing here. We want to be comparable to ourselves. And so now it's getting mad at us again. And it's that same method that's basically saying we didn't implement the interface correctly. Why is that? Well, notice here that the type is object, but now that we've specified a generic type, the method has actually changed. Notice the difference. Compare to is now comparing to a class or an object of my same type. So I'm going to get rid of this method now. Now what do we want to do here? We'll go ahead and give ourselves a variable, private int value. Let's tab that in appropriately. Give ourselves a constructor, public my comparable class. It'll take, what is this? Get rid of that. Okay. It'll take a int, init value. Value equals init value. Cool. And so what are we going to compare here? Well, remember the int here, what it's doing, right? We know that the myComparable class object has a value, and it's an int. And we know this. So we can use this to our advantage in determining which one is greater. In this case, we'll say between the two myComparable classes, whoever's value is greater will be greater in value, obviously. So here's what we do. We need to return an int. So value minus myComparable class dot value. And so what is this doing here? Well, it's subtracting the input myComparable class's value from the current class's value. And so if my current class's value is greater than the input parameter's value, then we're going to return a positive number. If they're equivalent, then, for example, 2 minus 2 is 0, the result would be 0. If the input parameter's value is greater than my current class's value, then what's going to get returned is a negative number. And this is how the compare to method works. So if we go back to our main here, and we can actually test this out. So we'll do my comparable class mgc1 equals new my comparable class 4. And so the input, that means the value for in my comparable class in this case will be 4. And so we're going to change the myGeneric class to be my comparable class. So immediately, you see some red squigglies. Cannot infer arguments. Once again, remember that saying we have a type discrepancy. So you specified that you want the type to be my comparable class, but you've given it an integer. So we need to change this to MGC1. And we'll go ahead and just do a print here and see how this looks. Well, that's weird. If we see the result here, it says my comparable class at, a bunch of garbage. And basically what that's saying is, if you remember, while every class inherits a toString method from the object class, if you don't override that toString method and it gets used, then what gets printed is that garbage, basically. So that's what we're missing. We need to override the toString method. So at override public string toString. And what will the result be? Well, it's going to be a string value or string version of our value. There's a few ways to do this. I'm going to use the integer class .toString method, give it the input of value. And so this is going to convert my int to a string. So now if we go back to main and we reprint, great, okay, so you can see 4. And so far everything's working as we would expect. But let's go ahead and make this a little more complicated. My comparable class, MCC, I think that makes more sense, MCC, I don't know why I call it MGC. MCC2 is new, my comparable class. In this case, let's go ahead and give it a greater value. Let's give it 8. And if I say MGC dot update item, and I give it this new variable I created, according to how we specified in our my comparable class, and based on how we've used the compare to here, I expect, or we should expect, that what gets printed now will be the my comparable class with the greatest value. So we can go ahead and take a look. We would expect it to be printing 4 and then 8. And that's exactly what we get. And just to further test our code real quick, mgc.update item, and we'll give it the original item, which now has a lower value than the current greatest value item. And we do mgc.print. And so since it has a lower value, nothing should change. And we can actually print that the return, print, if I could type, print ln, the return type of update item will be the same value as MCC1. So what's going to print here is going to be 4, 8, 4, and then 8. 4, 8, 4, 8. Good. So everything works as expected. So this concludes this example of how to use the comparable interface.